Hello, algebra students. Mr. Lawrence here, and we're going to do a review video for you. We're going to start off with our compound inequalities. The newest thing we learn is actually really pretty simple. Remember, when we see it written as one sentence, like in number one here, it's an and problem, right? It's an and. Okay, it might have the word and in it broken up into two, but it doesn't have to. And my goal is still to get the x alone. I don't like this 6 being here, so I'm going to subtract 6. But remember, I'm going to do it in all three places, right? And when I subtract 6 from both sides, all three sides, I guess technically I could say 4 is greater than negative 2x, which is greater than or equal to negative 2. Well, now I don't like that there's a negative 2 attached to x, so I'm going to divide by negative 2. But I'm going to have to do it here, here, and here. And when I do that, that's going to cause my inequalities to flip, right? So negative 2 is going to be less than x, which is going to be less than or equal to positive 1. Now I'm ready to graph it. And I need a number line. Number line. Oh, where are you? Number line. Okay. I didn't. Doesn't look like I gave myself enough room to do this. So I'll kind of fit it in and then move things over. Turn that into an arrowhead. Excuse me. All right. So, um, negative 2, positive 1. And if I need an open point at 2, negative 2, and I need a closed point at positive 1. And then I'm going to shade between them because the only numbers on the whole number line that make both parts of the inequality true, this part and this part, lie between negative 2 and 1, including 1. If I pick any number in here, like 0, negative 2 is less than 0, which is less than or equal to 1. That's true, right? Pick a number that's not inside the region. Okay, like say 5. 5's over here, right? Negative 2 is less than 5, sure. 5 is less than or equal to 1? I don't think so. Okay, so only the numbers inside the area there, that's shaded area, yield a solution to both parts. Okay, so let's see here. I'm going to give myself some room. I'll leave the number line because I'll probably need it. All right, with the or, many of you are very comfortable with it because you just see it as two problems. 3x is greater than 15, and then x is greater than 5. And you're like, hey, I got this, Mr. Lawrence. There's a 5, open circle, and we're going to shade going that way, right? Then you come over here and you go negative 1, subtracting 1, you get negative 2x. It's greater than negative 4. Then I'll divide by negative 2. And then x is going to be less than positive 2. So I need a 2. I remember I need an or here. So my solution is this. And I got a 2. And it's an open circle, open point I should say, right Dalton? And then I'm going to shade where the numbers are less than 2. And there you go. Ors will almost always look like that, except for that weird case we saw in class today. All right. I'm not going to do any more on that. You can go back and watch the video on those if you need some more help. Okay, so writing equations from 2 points. Well, before you do this, the first thing you're going to need is you're going to need a slope and then a y-intercept. I'm just giving myself a little more room to work here. Okay, so I need to find the slope, and most of you are really good at that. Let's find the slope. So m is going to be, let's do 6 minus 2 over 3 minus negative 9, and that turns into a positive. So I'm going to get a 4 in my numerator, a 12 in my denominator, and that's going to simplify to 1/3. So my slope is 1/3. Now, some of you are having trouble with this part. Here's where you take the equation y equals mx plus b, slope-intercept form. And you ask yourself, what do you know? Well, I know m. I just figured out m, so I'm going to put 1/3 in m's place. But I need to know b. If I knew an x and a y, I might be able to figure out b. Well, look at this. Isn't this an x value and that a y value? So I'm going to put 6 in y's place, and I'm going to put 3 in x's place. So 6 is going to equal 1/3 times 3, which is 1, plus b. And then I'll subtract 1, and 5 is going to equal b. Now that I have my slope and my y-intercept, I can write my equation. My equation will be y equals the slope times x plus or minus the y-intercept. In this case, the y-intercept is 5, so it's plus 5. If it had been minus 7, I would put negative 7, I would put negative 7 there, or minus 7. All right, let's try one more of those. Again, first step, I find my slope. So I'm going to do negative 5 minus negative 13. Okay, that's going to be an 8. My denominator is going to have negative 2 minus negative 6, which I believe will be 4. And so that'll simplify to 2. So my slope is 2. Now again, write down the equation. Y equals mx plus b. All right, I'm going to put 2 in for m. I need an x and a y. Well, here's an x and a y. So I'm going to put negative 2 in for x, negative 5 in for y, and I don't know b. So negative 5 equals negative 4 plus b. I'm going to add 4 to both sides. Negative 1 equals b. So I'm ready to write my equation because I know my slope and my y-intercept. Y is going to equal the slope times x minus the 1. And there you go. Pretty simple. Okay, graphing. We learned lots of different types of graphing. The first type was slope-intercept form. And look at problem number 1, or problem number 5 here. Y equals negative 1/4 x plus 3. Well, I know my slope is negative 1/4, and I know my y-intercept is the point 0, 3. So I'll plot the point 0, 3, right? And then I'm just going to use my slope to rise and run to get the other points. So the negative 1/4, so I can go down 1, right 1, 2, 3, 4. I could do another one from there and go down 1, 1, 2, 3, 4. Or I could have changed the negative to a 1 over negative 4, which means I'd go up 1 and back 1, 2, 3, 4. All right, so let's see here. Let's go from there. And I'll make that look like a line. Properties, arrowhead, a little narrower, and I'll make it blue. Okay, there you go. That is the black equation. Now I'm going to try the red equation. The red equation isn't in slope-intercept form. How do I know? Because the y is not alone. So to get the y alone, I'm going to divide by 3 here, here, and here. So then y is going to equal 2/3 x minus 4. All right, so I'm going to get negative 4. 1, 2, 3, 4. And I'm going to infinitely clone it. And then I'm going to use my rise and run. Rise 2, run 1, 2, 3. Okay, I could do another one. Rise 2, run 1, 2, 3. Or I could make them both negative, change both their signs, and go down 2 and left 1, 2, 3. And look, all 3 of those points are going to be on the same line. All right, I'll tell you what, I'll make this line, say, a greenish color. And I'll put an arrowhead on it. I know we don't normally do 2 lines on a graph. I'm doing it just for the less prep time. That's all. Okay, so there's slope-intercept form. Remember, y must be alone. Okay, standard form. Remember, in standard form, ax plus by equals c. And then I know some shortcuts. I know that the x-intercept is found by doing c over a, right? The y-intercept is found by doing c over b. And the slope is the negative of a over b. And remember, a must be positive to be in standard form. Well, since I have standard form here, 2x minus 3y equals 9, I can find my x-intercept, and it looks like that is going to be at 9 over 2, 0, which is 4.5, right? The y-intercept is going to be 0, negative 3, and the slope is going to be negative 2 over negative 3, which is 2/3, right? Okay, now I'm not going to use the x-intercept to help me graph. I'll use the y-intercept because it's easier. It's a little bit prettier. Infinitely clone you. And I'm going to rise and run 2/3. So rise, run. I'm going to rise to run 3. Okay, I'll get my line and I want to point something out to you. Let's see. I'm making it blue, I believe. 1, 2, 1, 2, 3. Okay. And we need an arrowhead on the end of there. I guess I can just draw one in. It will be okay. And remember I said the x-intercept was the same as 4.5? Look at this right here. Where is the line crossing the x-axis? 1, 2, 3, 4, 5. Right in the middle of 4 and 5. In other words, 4.5. All right. Now, problem number 8 is not in slope-intercept, or excuse me, not in standard form. I'm asked to do standard form, so I'm not going to divide by 5. I'm going to subtract 2x from both sides. And when I do that, I'm going to get a negative 2x plus 5y. That's going to equal 6. Problem is, a is not positive. So to change all the signs, without changing the numbers, I'm going to divide by negative 1. And when I do that, I will get 2x minus 5y equals negative 6. So my x-intercept is going to be negative 3, 0. I did 6 divided by 2. My y-intercept is going to be 0, 6/5, and my slope is going to be negative 2 over negative 5, which ends up being 2/5. It's just a coincidence that it's two negatives again. It won't always be that way. All right, so x-intercept is at negative 3, so 1, 2, 3, right? And let me see, I'm going to rise 2 and run 5. 1, 2, 3, 4, 5. Good. And then I'm going to rise 2 and run 1, 2, 3, 4, 5. And there we go. Get my line going here. And I think I'm doing that one in green. There we go. And there's that line. Okay. So there we are. Okay. So next type of graphing, point slope form. Remember, we have a point, and that's going to be negative 1, 3, right? There's the x-coordinate. There's the y-coordinate. Change the signs. And the slope is right here. And so we have negative 1/2. So I'm going to do negative 1, 1, 2, 3. And I'm going to use my slope. I'm going to go down 1 and right 2. Otherwise, I could go up 1 and back 2. Okay, so I'm ready to draw my line. This stuff, I'm going through it pretty quick, but it should be pretty simple for you. All right, there we go. And that's it. Now, in tomorrow's test, you'll be graphing on separate graphs, excuse me, on Friday's test. Okay, it's going to be the point 3, negative 2, and the slope is going to be 4 over 1. So 3, 1, 2, 3, negative 2, 1, 2. Looks like it's going to be there. And the slope is going to be 4 over 1. And so we're going to clone him. We're going to go up 1, 2, 3, 4, and then right 1. And we can go 1, 2, 3, 4, and right 1. And there we go. Uh, So 1, 2, 3, 4, 1. Something like that. And there you go. All right. Now, we do have some unusual graphs too, and they're actually easier than all the other ones. Unlocked. Unlock him and move him up a little bit. Oh, I know why I locked him. That's right. Okay. Now, some of you are going to have such a hard time with this, but all you have to do is make an input-output table. X and Y. Okay. And what do you want X to be? Well, I want it to be 1. What's Y? Well, Y equals 2. How do I know that? The equation said so. Pick another X. 2. What's Y? Well, it's also 2. How do I know? Y equals 2. All right, let's pick -3. What's Y? It's 2. I can just spot those points. I've got 1, 2. I've got 2, 2. And I've got -3, 2, which I think would be there. And we just end up getting a horizontal line. Now, you might be worried about the slope. Well, you can figure out the slope of this line real simply. Just count your rise and run. Just count your rise and run. Okay, so from this point here to this point here, how much do I rise? I'll call them points A and B. How much do I rise? Well, I rise 0. How much do I run? Well, I went 1, 2, 3, 4. So my slope is 0 over 4, but 0 divided by 4 is 0. Now, if you forget that, use a calculator. But 0 divided by 4 is 0. 0 divided by 5 is 0. 0 divided by 10 is 0. 0 divided by -13 is 0. The only number that's not true for is 0 divided by 0. Okay, let's look at the red one. X equals 2. Now, I'll bet, as smart as some of you are, you can make a prediction about what this line is going to look like. Y equals 2 was a horizontal line. X equals 2. What do you think it's going to be? Well, let's see. What's X? Well, it's -2. How do I know? Because X equals -2. Let's put 0 in for Y. Okay, what's X? It's -2. Why? Because it's -2 right there. All right, maybe I'll put 4 in. Okay, let's do one more. -2 for X and -1 for Y. Okay, I'm going to come grab these. So I've got -2, 0, which would be right there. -2, 4, which I believe is there. And -2, -1 is right there. All right, so it'll look like that. Because I can change the color so you can see the points better. I've been going with green, haven't I? All right, make it a little bit thinner so you can see those points. All right, there you go. That's your review video. Hopefully it helps. Remember, there's going to be review sessions Wednesday and Thursday after school, so hopefully you can make one of those. Mr. Lawrence signing off. Have a good night, everybody.